Okay, let's see if we can actually find the zeros of a polynomial function. In this first example, I'm given the function and it's in factored form. So that's going to make finding the zeros a little bit easier because a zero is what makes my function equal to 0. If I have the factors, I just look at each individual factor and say what makes that factor equal to 0. So for this first example, we're going to have x squared. Well, a 0 would make that 0. X minus 3, 3 makes that 0. And negative 4 makes the last one 0. So those are going to be my zeros. The multiplicity has to do with the exponents there. So I've got my zeros of 0, 3, and negative 4. My multiplicity would be 2, 1, and 3, right? I just use the exponents. Why that's significant is because when I have even multiplicity, I'm going to be touching or turning at that particular 0. So we're going to touch and turn at 0. At the 3 and negative 4, we are actually going to cross because those multiplicities are odd. Take a look at this next example. So I have 3 factors here, but you notice this first one doesn't have an x. So we're going to ignore that one. We only care about the factors that actually have an x in them. Ask ourselves, what makes it 0? Well, 2 and negative 5. Multiplicity, what are the exponents? 2 and 1. Why do we care? Because we're going to touch here where I have even multiplicity, and we're going to cross where I have the odd multiplicity. All right, let's take a look at a couple other examples. In these, we're not given the factored form. So that means we have to do some work, or maybe we can look at our calculator. For these, I'm going to go ahead and say, well, x is in each of these terms. Let's factor that out. That would give me a quadratic. That's pretty straightforward to factor. So when I factor it, I get x times x minus 5 times x minus 5. Because we want to talk about multiplicity, I'm going to condense that into the shortest form I can. I have repeated factors, so I write it as x times x minus 5 quantity squared. Then I determine my zeros, 0 and positive 5, and my multiplicities, a 1 and a 2. So we would cross at the 0, but we would turn at the 5. Second example here, very similar. The difference is we're going to factor out x squared to begin with, and then factor the quadratic. Again, it's a pretty quick thing to do. So you're going to have 3 zeros, right? 0, 4, and negative 2. What are the multiplicities? 2, 1, and 1. So you would be touching and turning at 0 and crossing at the other 2. All right, the next example here, this one is a degree 3, but this one is 4 terms. So remember, the technique for factoring is group up the first 2, group up the second 2, see what you can pull out in each case. This one factors very nicely, x plus 3, x plus 2, x minus 2. That's going to give me zeros of negative 3, negative 2, and 2. And each of those have an exponent of 1, so my multiplicity is 1, and be crossing at all of those. This last example, x cubed minus x squared minus 5x minus 3 does not factor like we just tried because there's nothing common here between the negative 5x and negative 3. So my technique in that case is to go ahead and graph it. So let me pull this up, x to the third minus x squared minus 5x and minus 3. Okay, and I'm going to go ahead and try the standard window, see how that works for me. I can always change that. All right, so I'm looking, and it looks like that might be a negative 1 right there. So I'm going to hit trace and say check negative 1. And sure enough, it tells me it's 0. So there is a 0. And because it's touching and turning here, that means it's going to be an even multiplicity, probably a 2. And then over here, let's see, that's 1, 2, that looks like 3. So let's hit trace again, 3. And yes, that is going to be a 0. So I have a 0 at 3. This one, it's crossing, so my multiplicity would be odd. We'll use 1. So if this is multiplicity 1, this is multiplicity 2, together that adds up to 3, the degree of my polynomial, and that works. So put it just here in the notes for us. At negative 1, this is going to be even multiplicity, and at 3, it's going to be odd multiplicity. Okay, these last couple examples, we're going to look at the graph and determine what kind of zeros we have. Are we having real zeros or imaginary zeros? How many of each? What kind of multiplicity would we be looking at? This first graph, I can see that it crosses the x-axis just one time right here where I've circled, and it crosses. So that's going to tell me it's odd multiplicity. So I have one real zero with odd multiplicity. And then what about imaginary zeros? Are there imaginary zeros? How would I know? Well, this particular graph has two turning points, so it means it's probably a degree 3 at least. I'm going to assume the lowest. So degree 3 polynomial, if I only have one real zero, that leaves two zeros that are going to be imaginary. All right, let's look at the second example. This one in green here, it crosses 3 times. So 3 real zeros, 3 places I see an x-intercept. This first one, it touches and turns. So that actually means even multiplicity. Probably we'll say 2. The next two it crosses, so odd multiplicity, we'll say 1. 2 plus 1 plus 1 would be 4. Okay, well, what kind of polynomial would this be? It's turning 1, 2, 3 times, ends are up, so I'm thinking it's probably degree 4 polynomial, and that matches my multiplicities. So there are no imaginary zeros on this one. So first one real zero and 2 imaginary ones. This one, no imaginary zeros, but 3 real zeros.